Welcome to Season 10 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day. Hello, everyone. This is Brent Wright and Joris Peels with the Prosthetics and Orthotics podcast. Joris is actually out gallivanting today, and so I have my colleague Katie Richmond with me, and I'm really looking forward to having this guest on as well. Katie, how are you doing?
Really well. Just, another day in the life of O&P.
So a question for you, Katie. You've been with Advanced 3D there now for a little while, and you've, for lack of a better term, drunk some of the Kool-Aid, right? So some of the lattice structures, powder bed fusion stuff, that sort of thing. What has surprised you the most in the journey, I guess, that you've been on?
I thought I had drunk the Kool-Aid before we started, and that's why I was joining you, but I don't know if it's truly surprising, but it does get to me that if there's a problem, we can fix it. The weirder, more complicated, messed up alignment, fit, whatever it is, whether digital is used throughout the whole process or just the beginning, just the middle, just the end, I can't imagine now a world where I'm not involving CAD as part of my process.
Yeah. Well, and then speak a little bit just to, you've used a ton of softwares, right? And now you're using a lot of freeform. For those that are not using freeform, what would you say is a benefit to Octane freeform?
Well, coming off of Mesh Mixer and Fusion 360 as my primary programs before I joined you at Advanced 3D, consistency is a big thing. Being able to take measurements compared to Mesh Mixer. Also, Mesh Mixer, and we just knew it was going to crash, and you just dealt with it and you kept going. So pretty fun not to have crashes. And as far as the number of times I would get stuck in Fusion 360 trying to work with organic shapes and it just straight refusing to keep going, that's not what it's like in freeform. In that and I've gotten to train a few more people on using freeform and helping them. And since I recently have only been learning myself, it's interesting because it's very much, okay, so tell me what you would do now. And they're like, what do you mean? I'm like, no. Just tell me as a prosthetist, what are you doing? Are you getting out a sure form? Is it a half round? Like, what are you trying to do? And I will tell you which button will bring up the tool you want, but it's still what you want to do. Are you doing a global reduction? And I think that is helpful to people because they're like, oh, well, I would do this in my plaster. I'm like, perfect. That is exactly what we're going to do then. We're just going to do it digitally versus other softwares was a little more convoluted, that this seems like an easy transition into doing it digital, but you're still doing what you know how to do.
Yeah. No, I think that's right. And I think using the haptic device also along with it, I call it the digital sureform. Like there's a lot of clinical stuff that happens that it very much moves over with the haptic device. So I think that's great. I also want to say that this episode is brought to you by Advanced 3D. Advanced 3D is a contract manufacturer. We do orthotics and prosthetics, but we also do a myriad of other things, which is a lot of fun. And so not only do we have nylon 12, nylon 11, color is one of our specialties as well. We've added multi TPUs, so any of the TPUs that you want or the TPAs, and then our newest material with the PK 5000 AM is a real game changer, I believe. So I'm excited about that. But we meet you wherever you are. So whether you're just learning and you're trying to figure out, hey, what scanner do I need to use? Or if you want help with software, automation, what have you, or you say, hey, I just want you to take care of it all and I want to see patients and play golf. We can do that for you as well. So, Katie, we have a long suffering guest, but we're going to have a lot of fun with our guest today because he is a freeform user as well. So I want to welcome Christiaan du Toit to the podcast. And thank you so much for making some time. So I've known Christiaan or Chris, he said, for the US people, we can call him Chris. So I've known Chris for a while. I love the stuff that he's doing. I love the way that he thinks about the problems in the digital space. And I think we have a lot of common interests. He's in Cape Town, South Africa. So that's pretty fun. So having international guests is always fun as well. And so we talk at all hours of the day, don't we, Chris? So we'll bounce ideas off each other. But he does some beautiful work, specifically in the orthotic side of things. We're going to pick his brain a little bit on that, and then with his newest venture as well. But one of the things that Chris does is there's not only function, but makes a beautiful device. And so if you check him out on LinkedIn and look at his header and down through his posts, you'll see why people like Formlabs and HP want his stuff in their booths, because it's just beautiful and functional at the same time. So, Chris, welcome to the show.
Hey, Brent. Thanks a lot. Hey, Katie. Thanks for having me, man.
So, Chris, we always start off with this question, and yours is usually the one asking it, but how did you get involved in orthotics and prosthetics?
I studied orthotics and prosthetics in South Africa. I took a year off after school. I didn't know what I wanted to do, to be honest. I shadowed with many clinicians, surgeons, therapists of all kinds. I've always liked working with my hands, and my grandfather was a doctor. I admired how he helped people, and I wanted to combine the two. And when I found orthotics and prosthetics, I knew it was a match. And so I went to go study. Back then, we only had a national diploma, which was a 3-year course, and that you could go further from that to a BTech, which is another 2 years, of which one is an internship year. And so I did the BTech. I ended up working for the government for a year or two. I was involved in a private practice inside a physical rehabilitation hospital for 5 years. And then I worked for another private practice here in Cape Town. And then I took a jump for the UAE, did a quick stint there where I learned quite a lot. And then I came back, furthered my studies for another year or two, and started doing freeform and just work for everyone where I can, anyone who wants to do any kind of 3D work. So that's the basic educational history. I think for me, I still remember the day when I first heard people are going to start 3D printing prosthetics. I laughed. I was all carbon fiber, lamination, let's go. That was my thing. It still is. I love carbon fiber. I love pre-preg. That's my new thing that I'm excited about. But I laughed. I really thought this can't be strong enough. The things I've seen is just impossible. Little did I know what lies ahead of me. When I went to the UAE, I went to go learn from 2 really brilliant German clinicians. And in their clinic, they already applied quite a bit of additive manufacturing. So that opened my eyes, and I saw there is a place for this. That's where I saw freeform for the first time. These guys strictly use freeform. Even if they're going to laminate, they obviously have the great milling machine, so all their positives are mold and not plaster. And that's where I saw the power of the software. And that got me really excited. I wanted to carry on learning, so I bit the bullet and invested my own money into it and just started learning the software. And all of a sudden I was doing things that I never thought I would before. And I just started testing, where is this applicable? Where isn't it applicable? And where does it have value for where I am? And that's basically the short of it. I remember also when I was in UAE, my boss sold me his little artillery Sidewinder X1. And that thing saved my life, man, because when I arrived there, it was the beginning of COVID. So we were locked down. and social was very low. So that thing kept me busy, and I just persisted. I broke it quite a few times. The journey of a tinkerer, and yeah, that really just got me my foundation of actual 3D printing. And then when I came back home to South Africa, I got access to an Octon license on an educational basis, as well as the one you like, the lattice systems. What is it called?
When we were using Entopology?
Yes, in
Yeah, yeah.
topology. That's correct.
Uh-huh.
So I had access to these softwares, and I really saw the potential. This was more or less in the time of the big hype. So now you see all these other software companies coming up, and they're making bespoke software specifically tailored for orthotics and prosthetics. And so I started looking around at these softwares, seeing if there's benefits to them. What's the difference between this and a powerful piece of software like Octon? And each one has its place. And so for quite a while, I was also doing some consulting work for Gespodo. Really learned a lot about the market as well. We went to OT World. That was great. Saw some of your stuff there, as you know, my stuff as well. And that brings me to where I am now. So during these past 3 years, basically did freelance work, and just like yourself, offering additive manufacturing services, whether it's design or 3D printing, to the OMP community out there. Also, still have my practice running in the background, so I can see my own patients. But right now, I've made the move to Cape Town, and we just started out. So it's very small still, just a few printers standing around. But we're focusing on doing 3D printing for people where it's needed, like government places where there's no lack of resources or skill sets, or NGOs is trying to reach out to people who can't afford prostheses.
So, that's quite a journey, Chris. I think one of the things that's interesting is it seems like each step of your journey actually build on itself. So obviously you had your foundational educational stuff. And it sounds like you were very much involved in the technical side. If you love the carbon fiber, so you were using your hands, plaster, all that stuff. Do you feel like that has given you an advantage moving now into 3D?
Definitely, I think so. I think, as someone, you can't just put a bunch of designers together, as you know, and then they're going to make orthotics and prosthetics. You need a clinician's insight into that. And I think, for me still, it would be great if we can say, let's 3D print everything. But there's still areas where you have to use carbon fiber and you have to do other methods of manufacturing. So I think it's really important to learn what is applicable and what is appropriate for where you are. South Africa is a little bit different. It's a lower middle income class country. So we really have to identify what will work here, what makes sense, and how do we apply it. Of course, we can't really afford just buying multi-jet fusions left and right. And our market is much more smaller. Our economy is very different to yours. So we have to think about it a little bit more carefully. And that's why I, as a company, as a business, that's my vision, is to identify these areas where we can fill the gap by bringing alternative solutions.
So with the 3D printing side of things, there's obviously you don't need a whole bunch of materials in a big lab and that sort of thing. But when you're looking out and the landscape and say in the present and then now in the future, do you believe that the 3D printing side of things also helps with other parts? Because I know, we have stuff that comes in from, Iceland. I don't know how you've got the Autobach, Iceland, feet coming in from all over the place, different pieces and parts. And 3D printing can solve a lot of that stuff without having to order that. I'd love for you to share a little bit about your thought process of specifically that when you're in South Africa, where, it does take time to get stuff in. So why not 3D print it?
That's great. That's a key principle here when you are out there looking for what is applicable. So, we need to understand that in South Africa, we're on the southern tip of Africa. So everything takes long, and there's customs, and it gets stuck, and then it gets lost. This has happened many times. So even if you like, the beautiful device coming from Invent Medical, it's going to take a long time to reach you. Sometimes the patient might just grow out of the device before you get it. So that's not applicable. It's very important that the companies that I like to work with, that they are more open platform. So, like let's take Gespoto, for instance. They're not telling you, listen, you got to use our materials, our machine, our white labeled, up-priced machine. They're not strict with what they want to offer. But, if you've got a company that gives you an easy solution to do the software and then says, here's your file, do with it whatever you want, share it, print it in any materials, we're only making suggestions for you. That's the kind of companies and, the kind of services that will work here in South Africa. So, we really need to be careful when we select these things because, like I said, you can't just buy a multi-jet fusion and then you didn't do your homework. You really need to think about the country and where you are and what is applicable. So FDM is really applicable in our country simply because we don't have a lot of SRS or multi-jet fusion services, and it's quite expensive still here. But there's a lot of things that can be solved with FDM, and it's just as great as if it was multi-jet fusion or traditional. And sometimes it's more cost effective, sometimes it's beneficial for the user, sometimes beneficial for the clinician. So you need to find that balance to see what works and what doesn't. So yeah, to come back to your question, it's really important to see, when you look at these technologies, how is it going to help the people in my country? Is it going to make the job easier for the clinician, and in what way? Why would he go through this learning curve, or why would he use your service? And then you must look if it's applicable for you as an individual manufacturing. Some things you can't print FDM, but if you find a gap and there's a need, you can fill it with FDM. So then you should do it. I also think with the components and the parts, yeah. So there are things that I believe we can definitely replicate. The Macy foot, of course, that's a great example of that. I saw another beautiful print on LinkedIn the other day. Someone printed a SMO with a shoe around it, just printed out of VarioSure or some kind of foaming filament, which is really great. So there's room for that too. And I think also for other kinds of, assistive devices, this is something you can print in your backyard with an average printer, things that help people with neurological conditions or physical disabilities.
Yeah, I think one thing that you hit that I find interesting, and I would say that I've evolved to that is, exactly what you're saying is that we're not talking about super high-end printers here. We're talking about FDM printers that are readily available. What is your feeling, though, on, we always say, people that are not clinicians saying they provide a prosthesis because a clinician isn't involved out of their garage. I do think that there needs to be some sort of balance. It's not that we don't, like, for me, like I do enjoy working for those people. And I think once we have a discussion, they realize, oh, maybe I shouldn't be working out of my garage offering these free prostheses because there's a lot more to it.
Mm.
I don't know how it is where you're at in South Africa, but what are your general thoughts about this idea of, yes, we're using a accessible technology. When I say accessible, like you can go buy it, but you don't necessarily have the clinical abilities to make something that's relevant.
Yeah, so that's very important. I think in my journey with Ugani as well, if I had to go as a one-man show and go to a big company and say, hey guys, I printed this in my backyard, they're going to think, who's this guy? What is he doing? A little Ender version 3. There's no proof of concept, and that's the important thing. We need to know these things are tried and tested and safe. So it's really important that you have the right partnerships and collaborations to be able to come with a product that you can say, look, it has been created and we have tested it. That gives you some credibility. It's very much more difficult to just launch a project from scratch, especially in the FDM world. So yeah, I think those guys who don't follow, the people who aren't careful in what they do when they, provide these devices, I think they just fall away anyway because they don't have that backing. They don't have that clinical perspective. They don't have the 3 million test results. It's just not there. So everyone at the end wants the best for their patients, and they'll select the best person for the job. So I think it's really important that in anyone who's going on this journey, look for something that's repeatable. If it looks a little bit questionable for you, go find the data, go see who the company is, go and see who the guys are, who's the designers, who's the clinicians, and what's their approach. And if it doesn't make sense to you, then it won't work.
Tell me, and I think you've touched on it a little bit, but tell me about Ortho Additive. You know, your company on the additive side of things. Kind of, what are some of your strengths? What are you looking to do? And then, touch a little bit more on what you're also doing with Ugani.
Yeah, so the remember that I'm a practitioner myself, and obviously I make use of these tools for my own practice. But for me, I think this is just a quick startup for now. It's obviously there's a lot of growth expected. What we try to do is, apart from, as I've explained, try to identify where there's a gap, where there's a need, and try to fill that with the benefits that come with additive manufacturing. And I think the future will hold, for us creating a digital asset library, workflows that we've created in free form and saved for all the things that, we know that the South Africans would want. And that starts, it starts small, but it grows quickly. So I'm looking for other people to collaborate with me, other designers. I'm sure in the future, things will get busy on the floor as well. So we'll have to get like a technician in, someone to run the show there. For me, I just want to grow the business, reach out to all the people where there's a need. And, we're currently doing some work with the government. And that's where Ugani also comes in. So again, I've decided to partner, or not partner with them, collaborate with them, because they've got the proof of concept. It's something that I can approach someone with and say, look, it has been done. So at the moment, we're doing a project with the government orthotic and prosthetic center here. We've got 25 patients that we're doing for them. They're also very interested in the technology. They really want to see if they want to buy into the technology themselves. They want to get used to the process, get used to using the software until they feel comfortable. So this is a great trial period for us. For Ugani, I'm just reaching out to other NGOs, other government facilities who are interested in the benefits of using additive manufacturing, offering them a service. And then the other products that we're working on right now are currently doing a collaboration with a very big company here in Cape Town called Shonaquip. They're a social enterprise, and they make products, wheelchairs, seating positioning devices for people with disabilities. Their market is mainly also NGOs and government, and we are trying to develop some 3D printed products for seating and positioning as well. So, that's kind of one side of it. But for the private sector, I want to be able to let them go and select a few designs on the website that they enjoy, that they think looks nice, will benefit their patients. They send us a scan, measurement form. We have a clinical discussion one-on-one, and we go ahead and design this brace and provide it to them out of our digital asset. So I think it's very important that if you want to go into the digital aspect, especially here in South Africa, you really need to go in multiple directions. You can't just be advanced 3D. You still have to be a clinician. You still have to be able to provide a product. I mean, as you mentioned earlier, you guys are not only printing 3D printed orthotics and prosthetics, you're doing other projects as well. And if you do this like multifaceted system, then you can really afford these things. You can really maintain all the licenses, all the designers, all the people on the floor. So it's organic growth and it's slow, but we've got a vision and we're working towards it.
So on that, we have a lot of people. Well, we have people that listen all over the world, and one of the most interesting discussions that we always have, and people will ping me and say, "Well, that was pretty interesting. How does one get a prosthesis, and how is it funded?" So you mentioned a little bit about the government stuff. You've mentioned some social enterprise stuff. I'm guessing there's some cash pay stuff. How does it work in South Africa?
Yeah, so our reimbursement is not bad at all, to be quite frank. We have very good clinical tariffs that we can bill. So we also have NAPI code system, which is our database of products that you can resell. So essentially, if I, create a wheelchair or something. I create a nappy code for that. I load it up to the system. The clinicians can then build this and process it with the insurance. The market in South Africa is quite divided. You've got the guys on really good medical aids, not going to lie. And then you have the rest of them that have nothing. So it's really difficult to find the balance there. Even people with medical aid often don't have enough funds, not even the bare minimum. And then it's a big fight with the insurance companies, and it's costly and it takes a lot of time. So it's a difficult market, but the insurance companies who pay well. And generally, we either claim from the insurance company or we charge cash. Obviously, a cash rate would be a little bit less expensive, but in general, we try to stick to the tariffs that our professional organization gave us so that we can create consistency within our insurance companies.
Let's jump in the weeds a little bit on the FDM side of things. So share a little bit about your journey into the FDM. What are some things that lessons learned, both good and failures? I mean, I'm sure you've never had anything, a print not finish on you. I mean, because you're Chris. I mean, everything works out perfect, right?
No.
So, but a lot of people, there's definitely a lot of focus on FDM. And what's interesting, when Joris and I were talking about the Formnext stuff, there's a lot of technology stuff that is coming out at Formnext around the FDM side of things. And I think it's for exactly the same reasons that you talk about, is that the powder bed fusion stuff is expensive. It is cost prohibitive in a lot of ways. These machines are expensive. The materials are expensive. The cost to run them is expensive. Where do you put them, and rent and people to run them and all that stuff. And so there's been a big focus on FDM. And so I would love to hear a little bit of your journey in FDM, and then share what you're able to share as far as, hey, materials you're using, what you're finding about nozzles, maybe even like speeds and that sort of thing. People seem to really appreciate diving into the weeds a little bit.
Yeah, so I think with FDM, the biggest learning curve is learning how to slice. It doesn't matter what design software you use, you really need to know what's going on in the slicer. And I mean, that took me years. It still takes me till this day, because once in a while there's new slicer settings. And you've got to figure them out and see if they will benefit you or not. But yeah, it's got its limitations, obviously, and there's areas where it shines. For instance, with foot orthotics, with the foaming TPUs nowadays, I don't see why anyone would not use that for foot orthotics. It's really enough, and it's better than the EVA traditional counterpart. It's much less expensive. It's much less labor intensive. There's no material waste going on. So that's a prime example of how something is really appropriate and efficient. You don't have to buy a super expensive machine. You can just get a bamboo lab or sidewinder. All of the stuff I learned was on that sidewinder, and I mean, I printed foot orthotics, SMOs, sockets, all kinds of things on there. And I know that many other orthotists did the same. Material-wise, I think my favorite at the moment would be polypropylene, just because it's so durable. If you think about it, polypropylene is Tupperware, this clicky stuff that, endears many clicks and opening and closing all day. And that's the same material that we're printing here. It's a little bit tricky to print, but once you get the settings right and the slicer right, it's really durable. And obviously now with the filament layers, it becomes a question of, will these layers separate? And again, it's more about how you position that device and how you do your slicer settings. They will determine the strength of that device. It's not about the material so much. I mean, I can print a socket in tough PLA, and that would probably also be fine. It's just not going to be as heat resistant and impact resistant as polypropylene. But yeah, if you're using polypropylene, you can really make some flexy, bouncy, spring-loaded stuff, and it's really just got to wrap your mind around how to design for FDM. The way you design something for FDM and for multi-jet fusion, it's quite different. You cannot do all the details. You'll just screw the printer up, to be honest. You've got to keep it basic, but you've got to know your parameters that work well with your materials. So obviously, for me, I've got my standard thicknesses, my standard strengthening areas, standard shapes that I know work with the printer that gives us more rigidity or more flexibility. And then it's just a matter of pushing the boundaries. I'm doing stuff with polypropylene now that I didn't think was possible a few years ago. And that's purely just because I've learned how to control the material better, how to slice it better, how to position the model better, how to design the actual brace better. I think also a lot of the work I do is pediatrics. When I say pediatrics, I'm talking about children with neurological conditions. So we're talking about cerebral palsy, spina bifida, and these conditions come with spasticity. And so you really, in some cases, quite firm, strong material to keep that positioning as it should be and to prevent the children from growing into a deformity. And, in my mind, that's pretty much only carbon fiber that can do that, or very, very thick multi-jet fusion. But as I've learned how to design better and to print better, with even if it's just PETG, you can get a very similar result, if not the same. But there are limitations. Obviously, you're not going to make a very thin strutted profile. It might snap off. You need to consider that when you're looking at your patient and thinking, if I need to 3D print this, is there a design that I can follow that will still work for the patient and is still acceptable to print? Even with the VarioSure materials, when I got it the first time, I was so excited how it works and it feels great and you can grind it and work it off. But it's got its own tricks as well. It foams like hell. So there's a lot of blobs and filament flying around everywhere. In the end, you just have to let it go and grind it off afterwards. Stop battling with the machine. But also overhangs is very difficult. It's always great when you have a dual head printer where you can print supports in some materials and the actual device in something else. But yeah, I think for FDM, the trick is really in the design and the slicing. It's not so much in knowing how the machine works or the technical stuff of the machine. In fact, just keep the machine so that it does the same thing. Don't tinker with it too much because it might just break. It's more about understanding the slicing settings and the material properties itself. So yeah, I've been printing a lot of foot orthotics and SMOs with these foaming filaments, a lot of AFOs, positioning AFOs and walking AFOs with FDM polypropylene as well, using pivot joints. It's very easy to integrate into the model. Printing inners for those AFOs with VarioSure foaming, any foaming TPU. And also PETG. PETG is great for check sockets. I just printed a nice clear PETG. I had to dry it for 6 hours, but it came out nice and clear. And I mean, it's nothing like the Filament Innovations 4mm, nozzles printing in 1.3 hours, but you can still see pretty much all you need to see through it. And that's an incredible tool that you can have, in your workshop, but you really need to understand what to do with the filament and how to slice it correctly and model it.
So what are you printing on currently? Have you played with any pellet machines? What are your build volumes? Some tech specs so we know what you're working with.
Yeah, so in the Ugani systems, we are using the FL-Sun V400. And, it's a nice shape for printing long devices, prosthetic sockets or, AFOs, things like that. And they're not expensive. They're not too complex. They're not too cheap either. They don't fall apart. They're quite reliable. I'm printing a lot of polypropylene PETG on there. And then, like I said, I've still got that little Sidewinder, and it's like my prototype machine. It's, I'm doing check sockets on there, even foot orthotics. I often put like a 1.8 nozzle on there just to see how much I can push that extruder. And then I've got a Raise E2, which is a dinosaur, but so reliable, man. It's just, I don't think I've ever had a failed print on that machine. And this is a great machine for foot orthotics, with the dual, and SMOs with the dual head extrusion. It really prints TPU very well. There are some upgrades you can do for it if you want to, but it's already not the cheapest machine to get in South Africa, so you don't want to mess around with it too much. I've got a Creality K1C that I also do prototyping and hobby printing on. And then, and then we've got a small resin printer as well if you want to, test some small parts, things like that. But otherwise, it's mainly the FL-Suns and the Sidewinder, the old faithful. And then, of course, for multi-jet fusion, we only have one company that does multi-jet fusion, as a service here in South Africa, and they're pretty busy. It's also, sometimes it takes a little bit long for our multi-jet fusion stuff. It's not very inexpensive in South Africa either. Obviously these materials need to come in as well. But, the parts are good. You can have it dyed black. Often, well, not often, but sometimes we hydro dip it. Looks great as well, especially for the kiddies. And then I haven't done any pellet printing. I've looked into pellet printing just to see what's available. Again, you don't want to buy an expensive pellet printer from overseas and then there's no spares and no support where you are. So you have to really choose what's applicable. I didn't find anything that I can manage myself. And also I found that the pellets aren't the best quality here in South Africa. They're not uniform and not necessarily the great sizes that we need for pellet printing. So that's not something I've done. I am experimenting with 2.85 diameter filament because it is something we can get here. So, that just getting higher flow rates, seeing what I can do there, that's on the cards as well. But otherwise, I keep to what is available, what is accessible, and, where can I get spare parts and things like that. Otherwise, it doesn't make sense. It's just too much of a risk to invest in that stuff.
So for the FL Sun and the artillery, like, how is it getting parts for those machines? Is it a difficult thing, or do you have to keep stuff on hand pretty much? How does that work?
Yeah, so luckily, because these are fairly common brands, and if you think about a Sidewinder, it's just basic components. It's not something that's very printer specific. It's just the average parts you would get for same stuff for your Creality or for your Soval or whatever the case. So, replacing those parts are easy. The Raise E2, we've got a very good distributor for Raise in South Africa, so I don't really have to worry about that. It is a little bit more expensive, of course, but it's got its place. And the FL Sun, we also have a distributor here in South Africa keeping spares on hand. But, again, keep stuff open platform. If it's going to be some kind of special nozzle from a special place in Sweden or wherever, you're going to sit with problems and you're going to wait long for spares. So you have to invest, like you say, in holding spares on site. So again, it would be wise to choose something that is accessible.
Yeah, no, I think that's an interesting point, and I think it's a point of experience too, right? So I think that's the one thing that I just gather from talking to you and just with art, the stuff that we're doing is sometimes we have a tendency to overcomplicate things, and the reality is the clinical abilities along with the knowledge of what is possible, which only comes from experience. I mean, you can teach some of it. That's what can make something successful. So I've always heard people talk about, it doesn't matter if you have the most expensive tool. If you don't know how to use it, then it doesn't matter.
Yeah.
Absolutely. And the same sort of thing, like a craftsman that does woodworking, he can do so much with a coping saw, a regular hand saw and some chisels compared to what I could do with $1,000 worth of the best tools available. They're going to create something amazing. So I think that's the other important thing that I really appreciate about what you're saying is that, I mean, the reality is that prosthetists and orthotists are craftsmen. We are clinical. We are technical. So it's like the whole thing all in one. And it's important to have that perspective because so many other times you might have somebody that's medical or you might have somebody that's technical, and there will be something that's lost in translation. Whereas a prosthetist can actually bring it all in because that's what we do. That's our job. That's what we've been trained to do. That's what the experience comes in. So I think that's really neat. Talk a little bit about the prosthetic market in South Africa and, as much as you can with some of the stuff that you're doing to grow Ortho Africa or Ortho Additive, sorry.
Yeah. So, like I said, there's the one side of South Africa, people who do make good money and they have good insurance and they go to private clinics and they get their prostheses there. In that market, you will find people coming to you, the clinicians, saying, listen, I see these guys are printing multi-jet fusion, where can I get this stuff? But for the government side of things, especially where we're involved now, the problem there is resources, the administrative system, things take long. So if you run out of, P-Lite, you're going to wait quite a long time. And the problem is the patients wait a long time. So often there's a lack of resources, whether it's skill set or clinicians or materials or technology. There's a big waiting list for all amputees. So what we're trying to do is we're trying to show the government that you don't have to rely on these resources anymore. All you need is a clinician who can translate that language into a digital realm, and then we can get these people on their feet faster. So they really love this idea, especially when it comes to the resource part, not having to spend hours and have a lot of clinicians on hand doing these things by themselves. The trick is to get that language, that clinical language, over onto the software, into the digital side. And I think, for the majority of clinicians, that's the thing that's withholding them from going into additive manufacturing. It's that learning curve. So, it's not easy to learn freeform from scratch. It takes a while. It's complex stuff, and it's not for everyone. I totally understand that. Yes, it does give you the most freedom and control, but it's not always necessary. I can design a foot orthotic on Gespoto software 10 times quicker. I can do it on, freeform. It's just not necessary to do it because Gespoto is tailored for foot orthotics. It knows that you want to do foot orthotics. So whenever I speak to people who, especially older clinicians who have been doing traditional stuff all their life, now they're becoming curious in this stuff. They either think it's a complete takeover and they now have to buy machines and learn softwares. And, why would they do that if they already have everything in place already? But that's generally where the block comes. Like, I think the big side of it is the rectification. As a clinician, I often, when I work with plaster, I close my eyes and I just feel, because that's what we do, is we feel our model, we work, we sculptors, like you said. And that's exactly what you're doing in freeform. You're sculpting with the haptic device. So that bridges that a little bit closer. It brings that, clinical language into the software a bit easier. Generally, I tell people, especially if they start out with software and digital transition, is, listen, if you feel like you don't trust the software yet, that's fine. It will take you years to get there. Do your stuff traditionally. Do your rectification traditionally, and then we scan the cost. The design is fun and it's easy in most cases if you know your principles. It's the rectification that really takes a long time for people to learn and to trust. So when I'm at the government and we see the patients together, I'm sitting there with the clinicians, and I understand what clinical requirements they need, and I know how to translate that into the software. So, by doing these patients together, they get a feel of this so that they can see if this is something that they can take on internally and then use the technology in their own facilities.
So I'd love to leave our listeners with a little bit of nugget of what is next, right? So what would you say to somebody that has seen something in one of the magazines or something, a clinician that is not using additive manufacturing at all? How do you start?
Where do you start and how do you start? Yeah, I mean, I know you usually say, start by scanning. I think that's great because it gets you an idea of how quickly and easily you can capture data instead of taking casts and making a mess everywhere. So it is a fun way to enter. But I really think people should forget about the printing side of things. There are people who can do that for us, people like you and I, people who understand the printers. You don't have to go through that learning curve. And also forget about learning how to do everything digitally. Just select easy things that make sense, like foot orthotics. Just do a demo. Go and find a software company you like, ask to do a demo with them, see if that's something that speaks to you, if it makes sense to you. The software is getting more intuitive and more tailored for a profession, so it's just going to get better. So I think that will address that kind of fear of how am I going to carry over my clinical expertise into the digital realm. So that's where I would say clinicians should start. In terms of technicians, buy a printer, take it home, play with it. Just learn how to print, how to use the software. And you'll never say you've learned it all because, it changes all the time and it just gets better and better as well. So, yeah, for the clinicians, I also tell them, listen, you don't have to You don't have to go all out, just try to understand the benefit for you as a clinician and try to understand the benefit for the patient. Sometimes there isn't a benefit for the patient. Some of my patients, it won't matter if I 3D print it or make it out of traditional methods. The thing will work the same way. But I don't have to stand in the workshop all day and make the device. So, like you said, now I can go and play golf. I just want to see patients and play golf. So that's kind of the service that we're trying to deliver to our clients as well. So I want to tell the clinician, listen, man, take your iPhone, take a scan, tell me what you need. Make your marks, do your corrections. If you want to do your own corrections, do that and scan the cast. And then leave the manufacturing for us because we understand what is important. We understand how thick it should be, where there should be strengthening, where there should be a lattice. So the other question I've been asked is, but I've now already got all the technicians and I've got all the machines. The traditional manufacturing system is there. That's right. You must remember that eventually that technician is just going to run the printer. He's going to learn the printer. Yes, there's less fabrication hours and less resources required, which frees your clinicians up to do other things. Let them learn printing while they're at it. So, it's a difficult transition because it is new things, but the great news is you don't have to jump into it all just from start. There are guys around who already do these things and who understand the clinical considerations that must come in. Like you said, if there's good communication between the design team and the clinical team, the product will be good. That's why, for our growth as well, I can't just depend on people sending us forms and measurements saying, I want this AFO. There has to be some clinical contact between us and the clinician, the client themselves. And that way that skill set can be brought over.
I think that's great. And I think the thing that is most profound in all that you've said is like it's a team and you have to be able to communicate. And I think that is actually one of the reasons why clinicians don't move to 3D printing is because clinicians, and I'm calling out myself, are poor communicators. They can actually make almost anything work, but if they get a device in, that's what makes a good technician or a clinician. And you can bring a device in that doesn't fit, and you can make it fit, right? But why doesn't it fit? Well, you poorly communicated the way to make it to begin with. And so I think that's one of the things, and I see a lot of really great clinicians just not starting because they're not good communicators. So I think especially as we're moving into the digital age, you have to be, if you want to be a good clinician, you also have to be a good communicator, which now that I'm saying that, it's like, yeah, duh, but that's not the case with our industry as a whole. So thank you for sharing that. I think that's
I
great.
also think, there's different personality types amongst these people. We all know designers and engineers are different to empathic clinicians, so to be able to work in a team like that is also a new thing. We see engineers entering our fields now, the designer kind of guys coming in. These are all kind of different personalities. So that's also why communication becomes even more important. But it's also, the challenge is also on the designers, the technicians, and the engineers is to pay attention to the clinical side of things and learn to understand it. Learn why I'm telling you to put 4 mil here and 2 mil there. And that's the nice thing with the technicians I've worked with in South Africa is they really show an interest in the clinical side of things because that makes their job easier for them. If they understand what they're doing better, if they see it more from the clinician's perspective, then they do a better job.
Yeah. Well, Chris, this has been great. I know our listeners are really going to get a lot out of this. So thank you so much for sharing your journey and the little nuggets of wisdom along the way as well. I know our listeners will take a lot away from that. So thank you for coming on.
Thanks for having me.
And Katie, thanks for being on as well. What are some takeaways that you feel like from Chris's kind of journey that is important for people that are looking to bring additive into their clinic?
I think it just sounds very similar to you and myself, that it's not about picking it because it's fancy or new, or it's about picking it because you've been there, you've done the traditional way, you've built things yourself, You understand what you need and how you would get there. And now you're just being smart about it. That it's not that you have to 3D print, or it's not that it's better for the patient, but if it's better for you, that means you can be a better clinician. So just a very similar experience from a different part of the world.
I love it.
Thanks.
And that's a wrap. Thank you for listening to the Prosthetics and Orthotics podcast. And a special thanks to Chris for sharing his journey and expertise. If you liked this episode, please leave us a review. And if you have any questions, critiques, let us know, direct message us, and we'll communicate from there. Have a great day.